Hi, Stuart again. Today we're going to talk about cloud for stakeholders. We're going to try to demystify some of the jargon and some of the techniques in cloud projects. So let's begin with kind of defining what is a cloud, because a lot of vendors say that their products are cloud compatible or cloud-like. Some say they have clouds, and depending on a certain point of view, they're both right and wrong. So I was trying to think about all the different cloud projects I've done at Magenic over the last decade or so. And I tried to come up with a set of criteria that sort of defines what a cloud is. Probably the most important thing is practically infinite resources. And then the availability of different kinds of application components. And they're all usually classified as, in the cloud universe, as a service. And then a letter before that. So infrastructure as a service, platform as a service, and so on. We'll talk about that more later. A real cloud is built on top of a high-speed, high-bandwidth network, so that networking should never slow you down. You should never run out of pipe, so to speak, in between your components. Everything should be sort of soft configured, that you can lay out your system or application in a way that you want. You should be able to spin up new infrastructure or conversely get rid of it in minutes or seconds, not weeks or months, right? And there should be lots of tooling, not only for management, but for monitoring and logging and performance assessment. And there should be durability features, such as more than one data center, right? Something happens to a data center, we want our system to keep running. We'll talk more about that later. And then, vendor support. It's really nice to have the proverbial throat to choke if something goes wrong, to get help on how to run your systems and applications in a way that makes the business happy. And the business is happy when customers are happy. And so part of that is having vendors to work with that can put you on the path to success. So here's the big logo slide. And in our opinion, all these things are clouds. Now, some of them are very special purpose clouds. Some of them are systems upon which you can build clouds. Some of them are clouds as a subscription, like Azure, Google Cloud, and Amazon, and IBM. Other things are components of clouds or special offerings that are done in the cloud software as a service. For example, Salesforce, Box, and Office 365, or all cloud-based systems. Which one of these you need varies based on what your business needs are. And so we have lots of other videos talking about that. But I just want to put it out into the world that these are all clouds that are designed to solve business problems at one or more levels of granularity. And the first column is what we typically think of as public clouds. That is, clouds you can go sign up and get a subscription for and pay as you go. And the next column are clouds that you can build in your own data centers using these technologies. The third column are clouds that exist out in the world that you have very little control over, but offer you, managed by somebody else, useful things like Oracle or Office or whatever. And the third category are all container systems, and we'll talk about those. And they actually can run on the first or second column of things. And underneath the covers, they may actually be powering up some of the things that are SaaS services that are in the third column. This is a subset, right? We didn't try to enumerate every possible cloud. There aren't enough PowerPoint slides in the world to do that. But here are the big major things that we run into regularly. The key thing about clouds is it's pay-as-you-go pricing. So it's the difference between renting and owning. It's the difference between buying a car and leasing it, right? Pay-as-you-go pricing. And that's good and that's bad. It's good because you only pay for what you use, But it's bad if you don't use an active management program that watches what you're spending and on what program and then what value you're getting out of the other end, and making sure that you're meeting your goals. And the primary goal is that usually it should make more money or offer more value than it costs. One phrase you hear thrown out around is hybrid cloud. And hybrid just means it's a mix and match, right? We go back to the logo slide and we're going to put some of our stuff on here and some of our stuff on there. We're going to leave some of our stuff in the data center. That's a hybrid. So let's talk about the as a service thing. This is probably way too much granularity for a lot of people, but I want you to just focus on the green-black trade-off. Green means it's your problem, your company's problem, and black means it's somebody else's problem. As we climb up the as a tree, right, from having our own data center all the way to software as a service, what we gain is that other people manage parts of this stack that are required to deliver any system. They become increasingly other people's problems. And as you climb this stack, we go from the Wild West, where you can sort of do anything you want, the things that are in the green, to having to do things in a more prescriptive way. That is to say, you get a lot of power because you don't have to turn the knobs and pull the levers yourself. But the flip side is you need to use it the way the vendor wants you to use it. That's what prescription means. It's important to know that for a whole software system, that you might have bits and pieces of that system across all of these stacks. We might have our main accounting system running in our company data center. We may have some third-party products running on machines up in the cloud, infrastructure as a service. We may be leveraging platform as a service or function as a service or software as a service for part of what we're doing, right? So you can, within one solution for each component, you pick the thing that makes the most sense. And in the aggregate, what you get is a system that does what the business needs it to do. Here's another buzzword: containers. In the beginning, there was hardware. And we put an operating system on the hardware. We configured the hardware. We had plugs and wires and all kinds of fun things and boxes with blinky lights. And it was good. Like, it was good that we had hardware. You still need hardware, by the way. It hasn't gone away. But what people started to discover was this business unit buys a bunch of hardware and they don't want to come up short, so they buy some extra. And this business unit buys some, and this and that and that and them and that. And so what you end up doing when you start measuring how much of that capability is actually being used in, useful ways, on average, it turned out that industry-wide, it was about 20%. So the other 80%, you were paying electricals, you were paying for cooling, you were paying for blinky boxes, you were paying for all this stuff, but you were kind of underutilizing it. But the flip side was that business units did not want to mix and match their software with somebody else's, because there was a very real possibility that when somebody deployed a new version of their software onto your shared machine, they'd actually nuke something important and your stuff would stop working. And that was not okay. So then virtual machines came along. And you can think of a virtual machine as being a whole computer, but entirely in software. And so what that allows you to do is you can then say, well, let's pool all of our hardware resources together. But each business unit will have their own virtual machines so that their stuff is separate, and that no one, if they deploy to their virtual machine, can break something running on our virtual machine. And that worked really well. And it led something called the utility computing movement. But they started looking at the utilization again, right? That's the amount, the percentage of our resources that are delivering business value versus not doing anything, which delivers no value. And they said, we really like the separation thing. And we like that we're getting more and more stuff on the same hardware thing. But we're still not seeing the utilization numbers we want, right? We really want to use resources more efficiently. And so a bunch of different approaches were tried over time. And the one that kind of won out was this idea of a super lightweight virtual machine. And that's a virtual machine that has built-in layers that and only has the things you need. And they called it a container. And the big names in that are Docker, Kubernetes, and Cloud Foundry. But essentially, they define a super lightweight virtual machine that has the same sort of isolation, right? So if my business unit deploys something, I'm not going to destroy the lives of the other business unit, right? The densities are way better, right? But here's the thing. Not everything will run in a container happily. Containers are a way of getting better densities for the applications that are suitable to run in containers. But sometimes we have to do a fair amount of code restructuring to make things run in containers efficiently. And because there's no point in moving something to a container from, say, a virtual machine and basically not getting any other benefits from it. We spent a lot of money to do the work. We're not getting any benefits, right? So we want to make sure we see a benefit. And the other thing is, frankly, there's just an awful lot of software that won't run in a container. And particularly anything that hangs on to data over a long period of time, right? They're going to be somewhere else. The data is going to be somewhere else. But the code your developers write, if they write it in a way that, and we'll talk about this, called the 12-factor methodology, it will run in the cloud generally very well. And specifically, it should run in a container, and you should be able to get that better density, better efficiency, right? More for your money than running on virtual machines or even bare metal. But virtual machines and bare metal, those things are not obsolete. What we've done is we've figured out how to move some of our workloads into highly dense, efficient mechanisms, but other things need bare metal or they need virtual machines. And so again, when we have a cloud, we mix and match the things that we have to get to the place that we need to get to. So here's just some really simple cloud architectures. It's way oversimplified, but just sort of give you a sense of it. So I have a generic cloud. My users come to my website passing invisibly through my security appliance, so that if they're evil users, we will hopefully stop them in their tracks. Our website calls a set of web services that call external third-party services. They call out of their application running in a container to a file storage into the database, right? And this is a pretty typical architecture. And you can see that it sort of underlines that point about using the right mix of the as-a stuff. So we have containers and we have platform as a service where the vendor is providing a file storage engine and we just pay for what we use. And the vendor is providing a database engine and we're just paying for what we use. And the vendor in the platform as a service case, the vendor takes care of all the care and feeding. So we can focus on the things that deliver business value, which are the code that we wrote and deployed to our website and web service. Here's another riff on that. All the same component. But in this case, we decided to implement our website and web services on virtual machines. And our database engine wasn't available platform as a service, or we didn't like it, or it didn't have some feature. And so we're running our database engine on VMs too. And we've just divided the world into the front of, the front end, that is things that face the internet, and things that don't face the internet, our storage and our database. And again, this underscores the fact that you in a cloud have lots of choices about mixing and matching, and they have costs and they have benefits. And working with your technical team, you do the analysis and you figure out what's the right thing for you to do for your project. So there is a website called the12factor.net. That's its URL. And a bunch of incredibly smart people got together and wrote this manifesto. There's about 2 paragraphs of verbiage for each one of these things, and said, if you're going to have a successful journey in building any kind of enterprise software, but particularly enterprise software that runs on any kind of cloud, that you need to consider these 12 things. So when you hear about we hear the technical people talking about fixing something or changing something or optimizing something, and you don't quite understand what they're on about, it's good to ask them to map it on to this. Like, what is this in aid of, this thing that you want to change? And how much is it going to cost? And what's the benefit? And so this is very common vocabulary for talking about not only migrating code to the cloud, but what we would have to do to, quote, modernize the existing code base to run in the cloud better, to make better use of cloud resources, and to get business advantage that we didn't have before. But again, nothing's free. There's a trade-off about how much you want to modify your code. And usually it devolves down to pay now and pay later. And it's just a judgment. Are we going to pay more over a long period of time because we didn't go through some of these optimizations? Or are we going to make an investment in making not just our software, but our whole process of how we build, provision, and deploy systems? And we're going to make it now and then pay less down the road, or have lower risk down the road, or have abilities that we wouldn't otherwise have down the road that benefit the business. Here's a buzzword you're going to hear a lot: microservices. So one of the things that makes systems really hard to maintain is having a big bowl of spaghetti as your code base. That is, you have this one big chunk of code and it does everything all in one place, as opposed to having like a Swiss Army knife where you've got different tools doing different jobs, and it's pretty obvious that they're separated. Let's say we have an e-commerce website. We use that because, that's a common scenario. Most everybody shopped online. You understand e-commerce, right? So you could visualize that they would need a product catalog and a way to search that, and a way to show products, and a way to add things to carts, and a way to check out orders, and a way to fulfill orders, and a way to manage payments and shipping, and blah, 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 blah. So if we think about those concerns of our system, and we implement each of those as a collection of functions separate from each other, what it means is that if we add a new payment choice, we can just modify our payment services and deploy that, and we don't have to deploy anything else. We may have to make some front end, changes to our website too, but it has a minimal impact, right? And the amount of things we're changing are relatively small, so our testing effort is relatively small. And if our testing effort is relatively small, we can ship smaller changes more often and address bugs or create new business opportunities much more quickly, and that's good for the business. One of the things the business cares about is still being here tomorrow, making money, hopefully. We talk about business continuation as a plan to resume business after something horrible happens. Business continuation is about preventing horrible things from happening where possible and recovering quickly from horrible things that happen if it's not possible to prevent them. High availability says that within a single data center, there is nothing that could happen to one group of hardware or part of our system that would take the whole system down. So if one computer fails or one blinky box networking thing fails, our system will keep running. It'll keep running with fewer resources, at least initially, but it'll keep running. That's fundamentally the idea behind high availability. Disaster recovery is about what happens when we lose a whole data center. And the origin of disaster recovery was the Cold War. What happens if the baddies nuke your data center or there's a flood? And the thought was, well, we should probably have our system running in 2 or more geographically separated places. And the major cloud vendors are fully aware of that. And so they tend to build data centers in pairs or triplets that are the magic distance apart. There's a mountain, there's something that separates them from each other, and so they're safe. From the point of view of us as business owners who want to have a disaster recovery, if we lose a data center, we want the system to keep running in the other data center. That's what DR is all about. And there's really 2 topologies. The most popular is that we have one data center that's our primary data center. And if something horrible happens to it, we fall over to the second data center. And if your system is really sophisticated and all of the parts of your systems will support it, you can actually have a much cooler layout where as users come to your site, that will send them to the data center closest to them or the data center that will give us them the best experience possible. And that's called active-active. It's harder to do. It's usually more expensive. But if your system is of a big enough scale, especially geographically, it's definitely a strategy you want to undertake. All the things we've been talking about boil down to a set of non-functional requirements. And there's lots of different lists of these. At Magenic, we've settled on sort of 10 high-level ones that we think sort of cover off on all the bases. Each of these non-functional requirements fundamentally addresses a question. For example, capability. Can it do what the business needs? And surprisingly, that's not a yes or no question. It does 80% of what they need, and the extra 20% isn't worth the money. So it's a continuum. All these things are continuum. For example, reliability. Is your system running well when it's needed? Well, you can have as much reliability as you're willing to pay for. And so depending on how mission critical, and by that I mean not the opinion of someone, but the actual financial analysis that says we can tolerate this level of downtime a year for maintenance, for outages, for whatever, and will still be a money-making concern. And if we were to go to the next level reliability, it would cost us X number of dollars a year. And if I can't make more than X dollars, then it may not be worth it financially to go to the next level of reliability. So each of these abilities addresses a big question. Let's talk about security, because that's the one that I hear about a lot from customers. And it's this. The cloud vendors, especially the major cloud vendors, Amazon, Microsoft, Google, can have an army of security professionals, and they can pay for the very, very best. They can and have designed clouds that are incredibly secure. But like everything else, how closely you followed the vendor's guideline and their best practices, and you followed security best practices in general, will govern how secure your system is. Let's talk about some headspace problems that I think as business people or as QAs or BAs or project managers, we need to think about. Because developers can sometimes be really blithe about some of these things. They're not true. They're not true in your data center, and they're way not true in the cloud. And these are the 8 things. I won't belabor them, but challenge, if you're in a meeting and you hear some of these things, right? You should challenge those as a product owner or a surrogate for a product owner, because they're not true. And some of these assumptions are in this list will cause you a lot of pain, and pain equals money, and money is about money, and well, so you don't want it. When you're moving to the cloud, Magenics actually identified another 8 that you have to be really skeptical of when you hear. These aren't necessarily 100% wrong like the last 8, but you have to make somebody prove it, right? It will be cheaper than running in your data center. Fine. You and the vendor have to sit down, show them what's running in your data center, say, this is going to run over there. What's it going to cost me for real? And, build that into your contracts and stuff. Don't take someone's word for it. Oh, it'll be cheaper. Remember, it costs actual money to do the move. So you've got to not only save money once it's running, but in saving that money, you have to recoup the costs of the move in the first place. And you have to do so in a reasonable ROI. The finance people are very finicky about that. If you hear some developer say, oh, the code will totally run in the cloud. Well, okay. I really like to have them do a POC, a proof of concept, and prove that to me, right? Bring it up in miniature, running up in the cloud, and show me that the primary business functions work. Migrating existing apps to the cloud is neither easy nor fast nor cheap. You should think about the fact that there'll be things that happen that take time to resolve. And so the traditional estimating model for data center movements, which is what a cloud migration is, don't really apply. If you're doing a complete greenfield, new software development specifically for the cloud, and you've hired yourself some ace cloud developers, then yeah, it'll probably be modeled just like you model the delivery of any other software for your organization. But if you're moving a data center, these things take time more than they take effort. I'll be honest with you, the cloud acts differently, and it acts differently in good ways and ways that may not be so good. And that's our jargon guide. Thank you for your kind attention.